Hi guys, this is your channel Stat and Math Tutorials in a new video. In today's video I'm gonna show you how to use the nth term to determine if a given series diverges. So let's start with the term. So the series En diverges if the limit of En is not equal to 0 or if the limit does not exist as n goes to infinity. So let's apply this term to a few concrete examples. So the first example is the series natural log of 1 over n. So let's find out what's the limit of natural log of 1 over n as n goes to infinity. So we know the limit of n over 1 over n as n goes to infinity, it's 0. And we know the y-axis is a vertical asymptote of natural log. So from the natural log graph, so the graph looks like this. And this is 1. So the 0 is y-axis, it's a vertical asymptote. So as 1 over n goes to 0, natural log of 1 over n goes to negative infinity. And negative infinity does not equal to 0. So that's mean, so the limit does not exist. So the series diverges. N equals 1 to infinity, natural log of 1 over n diverges by the nth term test. Now let's look at another example using the same technique. So the series cosine of 1 over n. So let's find the limit of cosine of 1 over n as n goes to infinity. So same thing here, 1 over n goes to 0. So that's mean cosine of 0 is 1. So this is not equals to 1. And 1 is not equal to 0. So the series diverges. Cosine of 1 over n diverges by nth term test. Let's look at last example here, which is the test will be n conclusive. So example number 3, the limit from n equals 0, doesn't matter, n equals 0 or n equals 1, so we have the denominator positive. So 1 over n plus 4, so the limit of 1 over n plus 4 as n goes to infinity, it's 0. So the test is n conclusive. So it's n conclusive. We cannot tell if the series converges or diverges using the nth term. So we need to do more testing here. maybe the ratio test, maybe the integer test, but the nth-term test is not telling us anything here. And this leads us to another theorem. So if the series an converges, then en goes to 0. But this doesn't mean if en goes to 0, then the series converges. And there is an example here, the harmonic series. So we know the harmonic series diverges. So n equals 1 to infinity 1 over n. So this is diverges. And even yet, the limit of 1 over n as n goes to infinity is 0. So here, if an goes to 0, does not mean en diverges. But, if an goes to 0, does not mean an converges. But if the series converges, applies, en must go to 0. So the harmonic series diverges because there is no upper bound for its partial sums. So this is a counterexample why the term is not equivalent. It's go only one direction but not the other direction. So what I mean, if an converges, then an goes to 0. So this is go just one direction, just this direction. So if an converges, that en goes to 0. But the other direction here is not true. So this is not true. If an goes to 0, doesn't mean an converges. It can converge, it can diverges. We don't know. So be careful with this term. It's just one direction term. It's not an if and only if term. So I will pause here, and I hope you enjoy watching this video. So thanks for watching, and see you next time.